Hello, Algebra 2 students, and welcome to Chapter 4, where we're going to be talking about quadratic functions, and we're going to be looking at parabolas and writing and graphing them today in Section 4.1. And we'll work our way through and talk about the properties. We'll get back into factoring in this chapter. We're going to talk about the quadratic formula. We're going to model. All kinds of stuff with that. So this is your introduction to Chapter 4, dealing with quadratic functions and parabolas. Okay? So if you take a look, first off, just starting a little bit with some definitions. First off, what is a quadratic function? It's any function whose highest power of x is 2. Okay? So whenever you've got x squared as your highest degree, those are considered quadratic functions. Okay? So anytime you're looking for the x squareds. The graph is U-shaped. It's called a parabola, as you've learned back in Algebra 1. Okay, so that hopefully isn't that big of a surprise. The vertex is either the high or the low point. So if your parabola is opening up, then you have a low point, you have a minimum value, very similar to what you had with the vertex of an absolute value graph, which is exactly why we did that right before this chapter. Okay, so you've got either minimum or maximum values, depending on whether the vertex is at the top or the bottom. There is an axis of symmetry, just like as we talked about with absolute value functions, and that is a vertical line of symmetry that goes right through the vertex and cuts everything in half, right down the middle. Okay, so just a couple of kind of definitions, just relating things back to the idea of absolute value. And like I said, hopefully now it's starting to make some sense why we did absolute value before this. Today's going to be the first of 3 different ways that you can write a quadratic equation. And we are going to deal with vertex form, which again should look familiar to you because from absolute value, the only difference is instead of having this x minus h squared, before we had absolute value bars sitting right here. Okay? So it is the exact same vertex form, except instead of the absolute value, you are now squaring x minus h. The vertex is still the coordinates hk, okay, just like in the absolute value. The axis of symmetry is still x equals whatever the x coordinate is of your vertex. Okay, it goes right down the middle. And the rest of the graph is going to come from the fact that we are going to move all of the points. We're going to deal with the horizontal shifts and the vertical shifts and all that kind of stuff. Again, very similar to what we did with absolute value. Okay? So just like we talked about before, same exact idea, but now with parabolas instead of v's. Okay? So let's move into that. So if we are going to go ahead and graph this, okay, the first thing that I'm going to do is I want to identify a, h, and k. Okay? So in this portion, let me go to the A is 2, which right away tells me that I know that this parabola is going to open up because it's positive. Okay? So I've got some information right away. H in this case is a negative 2 because remember when you look at the equation, the horizontal shift, which is your H, is always the opposite of what it looks like in the equation. So it looks like there's a plus 2. Horizontal is always the opposite. Okay? And k in this case is a negative 5. Okay? That is always the same. Your vertical shift is always the same as what it looks like in the equation. Which means, in this case, if I put those two together, that means the vertex of this parabola is the coordinates negative 2, negative 5. So I can start by plotting that point. So negative 2, negative 5, there's my vertex. And then I can use my a value, just like we did, to graph the rest of this. However, the a value with a parabola or anything other than your absolute value, you can only use it for the first set of points. So if I go from my vertex and I go up 2 and over 1 in both directions, there's my first set of points coming from the vertex. I cannot keep going because if I kept going, now it's going to end up looking like a V. okay? And this is a parabola. This is more of a U shape. It's got a curve in it. So in this case, I'm going to stop there and just kind of sketch in for now the U shape that we have. And as we work our way through the chapter, the idea is we will continually add more accurate points so that we can come up with a more accurate graph as we work our way through, okay? Right now, this is where we're going to start. Vertex, and use your A value to get your first set of points. And we'll go from there, okay? So there's your first graph. There's the idea that we came up with. If we continue on to another one, here's another example here. Again, I'm going to do it the same process. Okay? So A is -3, which tells me that this parabola is opening down. Okay? So I know I've got a downward opening parabola because it's negative. H in this case is +1. Once again, it's the opposite of what it looks like. Okay? So I've got a horizontal shift of +1. And then my vertical shift is right here at the end. My K value is -4. So that means the vertex of this parabola is located at +1, -4. So, and those are also our vertical and horizontal shifts of our parent function. So if we take a look, I'm going to plot that point first. We go over 1, down 4, which means there's my vertex. And we know this is opening down, so I'm going to use my A value to come up with the first set of points on my parabola. So down 3 and over 1 in each direction. And I'm going to stop there and just kind of scoop. I missed that point, but you get the idea. And just sketch in. I did a really bad job on that. Missed both points. And sketch in the parabola from there. Okay? So there's what that would look like. Then if we go through and let's say we are going to write an equation instead of graphing now, oops, let me go back. Instead of graphing, let's say now I wanted to write an equation of a parabola. Instead, I'm going to try to do this in vertex form as well. Okay, so remember, vertex form, y equals a times the quantity x minus h squared plus k. Okay, so that's what we have for vertex form as we work our way through this. And in this problem, what I need is I need points, or I need numbers, I should say, for A, H, and K. Okay? So the first thing we can come up with is they gave us the vertex. So right away, I know that there's my H and there's my K value. Okay? So I could go through and we could plug that in right away. Y equals some value of A, which we'll talk about, equal to x. Since I'm subtracting a -3, this is going to be x plus 3, quantity squared, and then a plus 6 at the end. So that's where we're at so far. But to finish this problem up, I need an A value to go with that, because there's a lot of parabolas that have a vertex of -3, 6. They might be skinny, they might be wider, they might have a slope of 1, they might have all of those. So we have to take a look at an A value that specifically will go through this point. And so if you remember, this is just some random point that we know that's on there. Therefore, that's an X and a Y value as we're looking at that. Okay, so I'm going to plug that X coordinate in for X into my equation. I'm going to take the 1 and plug it in right here for X. I'm going to take the Y coordinate, plug it right in there for Y. And so if that will then allow me to solve for A. So if we do that, I end up with -2 equal to some value of A, plug in 1 for X, plus 3, quantity squared, plus 6. And now I have one variable that I can go through and solve for, which is A. So I'm going to go through and deal with this portion first, right here. I'm going to get an answer for that. So as we take a look, 1 plus 3 gives me 4. 4 squared means that I've got 16A right here in that spot. Okay, equal to -2, still a plus 6. And now I solve for A. Subtract the 6 over. That will give me -8 equal to 16A. Divide both sides by 16, and I find out that A is -1/2 when I divide by 16. So now I've got the a value and I've got h and k. Therefore, now I can write my final equation of y equals negative 1/2 times the quantity x plus 3 squared plus 6. Don't forget the squared. This is a parabola. Okay? This is a quadratic, so you got to make sure you have the squared in there. And there is the equation that goes with that. Okay? So ultimately, and hopefully this a being negative is not a huge surprise, because your vertex, if you go to the left 3 and up 6, this point is below that vertex, which means the parabola has to be opening down. So if you kind of think of that as well, that will also help you out. Okay? So in this, we're looking at vertex form, how to take something that's in vertex form and graph it, or how to take some information from the graph and come up with the equation. Okay? So that's what we're taking a look at. Your practice to learn for this lesson is the 4-1 worksheet, where you'll work your way through these different pieces, do the best you can on it. If you have any questions from the lesson, if you have any questions from the worksheet, we will talk about that when I see you in class. Good luck with everything.